Okay, so section 2 is the derivative. So basically I was being a little sneaky in section 1 and not telling you that the slope of the tangent line is also known as the derivative. So that's another name for the slope of the tangent line, or the instantaneous rate of change, or instantaneous velocity. You find all of that by finding the derivative. So some notation for the derivative. We read this as f prime. There's a little apostrophe there. It's not f to the first power. It's an apostrophe. So f prime of x, y prime. This notation is supposed to invoke slope. So it's supposed to invoke how we say delta y over delta x for change in y over change in x, because you do y2 minus y1 over x2 minus x1. So it uses a d instead of delta because there is no change for a derivative. There's no change in y because it's an instantaneous change. So it uses a d instead of a delta. So that is dy dx, and then d of f of x dx. So sometimes you'll see actually the function put in here, like if f of x was x squared, you'd have dx squared dx. So sometimes it's written that way. The definition of the derivative, so these were what we did last time, all right, in the notes. It's just in formula form, I suppose. So f prime of x is the limit as a goes to x, or you can do x goes to a. The order of that doesn't really matter. Of f of x minus f of a over x minus a. Or you can do the H method. And I think I said last time, you can do H's, you can do A's and X's. It doesn't matter. The difference between them typically is this one you factor, this one you FOIL. All right, they do the same thing. I don't care which one you use. The AP exam doesn't care which one you use. However, you do have to recognize both of them. And we'll do a little exercise on that down at the bottom. So first one, we want to find the derivative of f of x equals 1 over x. So I will set it up both ways. To solve it, I'm just going to do the x's and a's, but you solve it, it's the exact same steps to solve the h version of this. I don't use the formulas. I set it up exactly the same way we did with last section for the last example. So to find the derivative, you need two general points. So one point is going to be x comma 1 over x, and the other point is going to be a comma 1 over a. If you want to memorize these formulas, you can do that. I just don't like to memorize formulas. So I prefer to remember, oh, derivative is limit of slope. Here's my 2 points. All right, so I'm going to set this up, y2 minus y1 all over x2 minus x1. All right, and then if we were to do the h method, we do x comma 1 over x, because that's our function, and then x plus a little bit h, and then 1 over, we're going to replace this x with x plus h. Okay, and so then we do the limit as h goes to 0 of 1 over x plus h minus 1 over x, all of that over h, again, because x plus h minus x is h. Okay, so you're going to end up, I mean, it'll look a little different as you solve the limit, but it's going to be the exact same steps. All right, so the first thing that I would do is get rid of the kind of improper fraction. We want to get a common denominator. This is why when we were doing limits in the third section of the limits unit that we did problems like this, is because for derivatives, you've got to do stuff like that. So we're going to multiply top and bottom by 1 over x minus a to get rid of the awkward second denominator. So we have the limit as a goes to x. I'm going to distribute that to the numerator. So we're going to have x times x minus a minus 1 over a times x minus a. And then we want to get a common denominator. So our first step here would be to multiply by 1 over h on top and bottom and then get a common denominator. So same set of steps. If we look at our two denominators, they both have an x minus a in it. This one has an x, that one has an a. So we're going to multiply the first one by a over a, and we're going to multiply the second one by x over x. I'm going to kind of skip a step here and just write it as one big fraction. So our numerator is going to be a minus x. Our denominator is going to be a times x minus a. So it almost cancels, but not quite. So we're going to factor out a negative from the numerator so that it's in the right order to cancel. and then we can cancel. And then we want to replace both we want to get them to be the same variable. So we're going to replace the a with an x. So it's going to be negative 1 over x times x, or negative 1 over x squared. All right, so there's our derivative. You'd get the same thing with this one. You just will do slightly different steps. It'll look slightly different, but it's the exact same steps. All right, so I want you to try to find the derivative of y equals the square root of x. You're going to have to multiply by the conjugate to solve the limit, but at least try to set up the limit for that. So the second part of this is we also need to be able to recognize the difference quotient. That's what these are called. These are called difference quotients. We need to be able to recognize the difference quotient as a derivative. So if they give you, especially something with the h's in it, if they give you something like this, the first thing that you should say is, oh, that's a derivative. Now that doesn't mean a whole lot to you right now, because to find the derivative, you'd have to solve the limit, and that's just what you'd have to do. But later on, you won't have to take the limit to take the derivative, and you'll be able to take the derivative a different way. So if you recognize this is all over the multiple choice on the AP exam. If you can recognize this as a derivative, and you can take that derivative a different way without evaluating the limit, it makes it a lot easier. So to be able to do this, we need to identify what function this is taking the derivative of, and what the point is, because these are not like these where we're finding a general derivative. This is like the first couple of examples that we did last time on the notes, where you had an actual number. So we were finding the slope of the tangent line at a number. We're finding the derivative at a number. So this limit is equal to f prime of some number a. All right, our goal is to figure out what the function is that we're taking the derivative of, and what the number is that we're taking the derivative at. All right, so with this, so I have one in each form. All right, this is kind of the x and a form. This is the h form. So in the x and a form, your number that you're taking the derivative at is right here. All right, super easy. That's our x value that we're taking the derivative at. So our a is 5. All right, then it should be that whatever is right here is f. All right, as you might be off by a constant or something like that, like if they combined the constants, so you may want to double check that it's correct. But anywhere you see an x in the numerator should be f of x. So this is going to be 2x squared. Now we could double check that it's not like 2x squared minus 1 and they combine the minus 1 right here. By plugging 5 into this, it should work out. If we plug 5 in, we get 25 times 2, which is 50. So yes, we should see that there, even if they combined constants. Like this is typically the best you can do for f of x. Like it could have really been 2x squared minus 1. We don't know. It actually doesn't matter for the derivative. Like if you were finding this f prime of 5, it wouldn't matter whether you had a constant here or not. So it kind of doesn't matter. But you need to be able to pick out your f of x and pick out your a. For the h form, so what is f of x? I phrased it a little bit differently. What value are we finding f prime of? So this is f prime of some a, some value. All right, a is our answer to this question, and then what we're finding the derivative of is the answer to this question. So if we look at this, this number, or this number with the h, that's your a. So this is 3. The answer to that question is 3. And then your function, if you go back up and look at the formula, I know I said I don't memorize formulas, but it's f of x plus h, and this is f of x. All right, so if my a is 3, then this is my f of x, which is square root of x. All right, you just replace the 3 with an x. Same thing here, we see the x plus h, so this is going to be my f of x. So then you have one to try, similar to the first example up there. So my f of x is square root of x for that one.